Okay, you had some questions. Okay, you had some questions too that you didn't understand.
Yes.
Did you had some questions that you didn't understand?
Pardon?
Okay. Asking, I said, were there some of the questions? Were there some that you didn't understand?
Yes.
Okay. Those ones among the simultaneous equations or the ones on difference of two squares? Or was it both of them?
Both of them.
Okay. Okay, maybe we would find time to look at them. But were there any ones that you were able to solve on your own? Were there some you were able to solve on your own?
Yes.
Okay. Okay, so maybe we'll do this. Just do your best to send me the ones you were able to do on your own. Let me just take a look at them to see how good your understanding is of it. Then we will now work on the ones that you were not able to do on your own. Would that be good?
Okay.
Okay. All right. So let's see. Okay, we can start with question. Which year is this? 20. Okay, I'm not sure I can see the year, but okay, 2022. Okay. Okay, all right. I think we can move on to the first one. Are we starting from the top?
Sure.
Okay. All right. This one should be easy for you. 40 centimeters into millimeters. Yeah, that should be easy. 10 millimeters make 1 centimeter. So if I'm changing centimeters to millimeters, I'll be multiplying by 10. So that would be 400 millimeters, because 10 millimeters make 1 centimeter. So in each centimeter, there's 10 millimeters. So I'll just multiply 40 by 10. The next one is simple. If there is a 1 in front of each of the e's, then that would make it 4e. And then I think that's it for question 1 and question 2. Could you scroll down? Let's take a look at question 3 closer. Okay, looks like it's a translation thing. It says on the grid, reflect the shaded triangle in the mirror line. So a reflection is simply it's basically a translation, right? Inverted. So it's simply going to be this triangle on the other side. So they will share the same basis, but the top of the triangle will be pointing towards towards the left hand side. Okay, so can you do a sketch for me? Let me see if you understand what I'm saying. Can you do a sketch for me to know exactly where the reflection would be? Should be pointing towards the left hand side. Yes. Okay. Yes, exactly. You need to gauge it. Okay, perfect. All right. Okay. 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 All right. Okay. So yes, I think I can see you understand it. Okay, that's cool. Okay, let's move on. Okay, this one says write down the value of 6 in the number 16,007. Okay, so I mean it's it's pretty straightforward. It's 6,000, right?
Yes.
Okay. Okay, so we're moving on. Write these numbers in order of size. Start with the smallest number. Okay, so we know half is 0.5 and 0.55 is bigger than 0.5 by virtue of the 5 after the first, excuse me, after the first 5. And 45% is 0.45 because 45% is 45 divided by 100. Okay, so remember, whenever you divide by multiples of 10, right, the decimal point moves to the left according to the number of zeros there. So 45 divided by 100, which is 45%, the decimal point will move from the behind the 5 over the 5 and then over the 4 towards the left hand side, making it 0.45. So that means the smallest, as far as we are concerned, is 0.45, followed by 0.5, followed by 0.55. Do you agree with that?
Yes.
All right, so we move on. The pictogram gives information about the number of hours of sunshine on a Saturday and on a Sunday. Obviously, it looks like we had more sunshine on Saturday by that pictogram. Pictograms are really nice because they show you the accuracy and, the data from a good standpoint just because they are pictures. So it says each of those sunshine things represents 2 hours of sunshine. So the question is this: work out the number of hours of sunshine on Saturday. So Saturday has 4 of those sunshine things, right? Icons, if you want. So 4 times 2, because each of them is 2 hours of sunshine. That will give us 8 hours of sunshine. So I think that's the answer for that place should be 8 for Saturday. And if they're asking for Sunday, then that would make it 4 hours because we just have 2 of them. That's 2 times 2, which is 4. Okay, so you're good with that?
Yes.
So we can move on. Simon buys some candles. Each candle costs £2. Simon pays with a £20 note. Okay. He gets a £6 change. Work out the number of candles Simon buys. Simple. We'll subtract the change from £20 to give us 14, right?
Yes.
We will divide by 2, that's 7. So that means he bought 7 candles. Okay. So do you good with that, or you want to write down the working?
No, I'll have it.
Okay, all right. Okay, no problem. Let's move on then. Okay, what does this next question say? Oh, it's a bar chart. The bar chart shows information about the total rainfall each month for 4 months in a city. Okay. April, May, and June. So in May and June, we didn't have, okay, apparently. So they now said in May, the total rainfall was 35 cm. Okay. In June, the total rainfall was 20 cm. Use this information to complete the bar chart. Okay. So if you were to draw the bars for May and June, where would they be? Following the scale that we have here. Remember that May is 35% and 35 cm, sorry, not percent. So let's see how May and June will play out. May is 35 and June is, okay, yes, that's for May, yes. Then let's see for June. I think that pencil thing is blocking it.
I was 20.
Okay, 20. Yes, perfect, perfect. Thank you. Okay, it's fine. Okay, let's move on. Rupa says in February there was 15.5 centimeter of rainfall because the bar is half of a square above 15. Explain why Rupa is incorrect. I guess the scale says it all. The scale is not the scale is not does not say each box represents one. If for Rupa to be correct, then instead of us to have 20 after 15, we would have 16. Okay, but obviously it's not 15, 16. Each box is not 16. It's not one, sorry. So Rupa is definitely incorrect. But for us to further explain why he's incorrect, let's establish what the scale is. Each box is 5 centimeters. So what that means is that where it is for February, February is actually half of, we are going to divide 5 by 2, and that's 2.5. So February is actually 17.5, okay? If we wanted to be accurate about where February is, it's actually 17.5. If we are saying 15 plus 2.5, okay? Did you get that?
Yes.
That's the reason why Rupa is incorrect. His interpretation or her interpretation of the scale is faulty. Okay. All right. So it looks like another translation question. Pattern 1, pattern 2, pattern 3, and it says on the grid below, draw pattern number 5. Okay. So it looks to me as if the patterns are increasing by one box each as on the right hand side and below. So yes, that's what it looks like it's happening here. So for pattern 5, I'm going to have how many boxes? That's going to be
9.
5 boxes, right? So do you want to do a sketch? Let's see if we'll boxes up and 5 boxes down. So just do a sketch. Let's see if you have something. You can just do a rough sketch. It doesn't have to be with a ruler. You can just do a rough sketch, but just make sure you do it with the number of squares inside. Okay. Okay. Yes, exactly. All right. 1, 2, 3, 4, 5. Good. Okay. That's vertically. Let's see horizontally. So you do another 5 from that place where you stopped. 1, 2, 3, 4, 5. Okay. Okay, perfect. Okay, nice. Yes, nice. Okay, that's nice. Good. Perfect. Okay. Okay, it says complete the table. Pattern number 1, number of squares 1. Pattern number 2. Okay, it's pretty simple. 5 would be 9, isn't it?
Yes.
6 would be 11. Okay. Okay, so I think we can move on. Okay, it says in Norway last year, the lowest temperature was minus 15 degrees Celsius. In Norway last year, the highest temperature was 42 degrees Celsius, greater than the lowest temperature. Okay, so it now says work out the highest temperature in Norway last year. Simple. Since it says it was 42 degrees Celsius greater than the lowest temperature, we'll simply add 42 degrees Celsius to minus 15. Okay, so remember the rule for when you have negative on one number and positive on the other one. Minus 15 plus 42. What would that amount to? What do you remember the rule?
It's gonna stay positive.
Yes, it's definitely going to be positive. So what do you think the answer would be?
It's minus 15 plus 42.
Yes, minus 15 plus 42.
On 27.
Yes, correct. So that's going to be 27 degrees Celsius. Okay. All right. Okay, so we can move on now. The next question says, at the end of October, Fiona's electricity meter read 88,738 kilowatt hours. At the end of November, her electricity meter reads 89,198 kilowatt hours. It says each kilowatt hour of electricity Fiona uses costs 16 pence. What does it say next? Work out how much Fiona had to pay for the electricity she used in November. Okay, that's simple, right? We'll simply subtract 88,738 from 89,198, and then we would multiply our answer by 16 pence, right?
Yes.
So so you want to do that quickly for us? Now remember, this looks like calculation that you can do mentally. I mean, it looks like things that have even been arranged for you. From a bird eye view, I can simply do 8 minus 8, 0, 9 minus 3, 6, 11 minus 7, 4, and I have my answer. That's 460. Okay, I didn't write down anything. I'm just from looking at it. 460. So now I need to multiply 460 by 16, which is as good as 46 times 16, and then I'll just put a 0 behind it. Okay, so can you quickly do that one? I think you can annotate on, you can write on that space. Just quickly do the 46 times 16 here, then we'll put a 0 behind it as our answer. Okay. You still put the zero behind. Okay, no problem. It's just it will take you longer to solve it if you did it this way. Okay. So what do you have?
Sorry.
You understood what I was saying, right? 46, it's 460 by 16, right? But there's a concept that we understood, that when you have a zero at the back of any number, that zero is as good as multiplying that number by 10. So you can just ignore the zero and do your other multiplication and then put back the zero on the answer at the end of the day. Okay. Okay. All right. Good. Okay. Okay. All right. So that's going to give us 7,360. Perfect. And it's pence. So if you wanted to put it in, okay, why are we supposed to change the answer to pounds? Let me see what it says. Where does it say we should write the answer? At the bottom there.
Work out how much you're gonna pay for the electricity.
Okay, that's fine. So you could either leave it as pence or convert it to pounds, right?
Yes.
Okay, that's fine. Right, so let's move on to the next question. Okay. Okay, this one is addition of fractions. Okay, so can you quickly do this for me? You know how to use the LCM method, right? Find out the LCM of 12 and 6 and then do all that stuff.
I believe so, yes.
Okay. Okay. Are you annotating on the screen, or we okay, 5/12, yeah, plus 1/6. Okay, okay, okay. Oh, that's nice. Okay, that's fine. Okay, I like this method. That's fine. That's good with me. So you know what you just did now is similar to what we did back then when we were doing things like one minus a fraction, or one, that kind of question, where you understood that one is as good as the a number divided by itself. It's similar to this. Okay. All right, that's fine. I like this method. It will make you faster. Let's move on to the next one. It says work out 3/10 times 5/8. Okay, so this is pretty simple, right? The 5. Now, I'm not sure we've done a question like this, but let's just see if we can quickly talk about it. The 5 would take itself out. 5 in itself is 1. Now, the 10 that's under 3, the 5 will cancel the 10. Will go into the 10 two times. So the basic rule for this guy is that only you can only take out things crosswise. You can't take out things that are on the same level. Okay, so the 5, you can only do numerator to denominator or denominator to numerator. You cannot do numerator to numerator or denominator to denominator. Okay, so what we're going to be left with is 3 times 1 divided by 2 times 8. Did you get that?
Yes.
Okay, so that's going to be 3 over 16. Am I right?
Yes, 3/16.
Okay. All right. Okay, so we move on. Okay, so the next one says there are 15 sweets in a jar. 4 of the sweets are red. Looks like a probability question. He takes at random, it is probability, a sweet from the jar. Write down that the sweet is red. Okay, so can you help us with this? Probability, remember the formula for probability, number of required events over number of possible events. In other words, over the total. Just summarize it that way. So what would this be?
4/15.
4 over 15, yes. And we can't break it down beyond that. Okay, the next one says, there are only green counters and blue counters in the bag, only. We don't have any other colors there. It now says the counter is taken at random from the bag. The probability that the counter is green is 0.3. Okay, find the probability that the counter is blue. Another way of asking that question is saying, find the probability that the counter is not green. Simple. Okay, that's just another way of saying it. So if the probability of the counter being green is 0.3, what do you think will be the probability of the counter being blue?
0.7.
Perfect, perfect. Because total probability is 1. Thank you. So I mean, it's quite obvious. If you wanted to show a working for that, all you just needed to do is to say 1 minus 0.3. Okay. So I think we can move on. Okay, this is a linear equation. It says work out the value of y when x is equal to 4. Substitution, pretty simple. All you just need is your multiplication table. You need to be sound with your multiplication table. So I have y equals 6x minus 5. And x is 4. That means 6 times 4 minus 5. So what is 6 times 4? Do you remember?
24.
24. So 24 minus 5 is
19. Sorry, 19.
19. Yes, 19. So that means the value of y is 19. Okay. So I think that one pretty much solves itself. So let's move on. Okay. This one is talking about estimates. It says work out an estimate for the value of 92 times 1.63. Okay, you must show all your working. Okay, so if we're working out an estimate, I think we should take that 1.63 to the nearest whole number, right? So if you were to round up that guy to the nearest whole number, what do you think it would be?
163.
To the nearest whole number?
Oh, 2.
2, yes. So that would be 92 times 2. So I mean, that's 2 times 9 is 18. 2 times 2 is 4. That's 184. Okay. So I think that's a safe estimate if we were to excuse me.
Do we have to estimate the 92 as well?
Okay. Okay, to 90, right?
Yeah.
Okay. Okay, so yeah, if we do that, that would be 90 times 90
2.
times 2. So that's 180. Okay. Okay, that's fine. So would that would balance both sides. Okay. Okay, that's fine. Okay. It says given that 2.96 times 3.2 equals 9.472. It says find the value of 29.6 times 32. All right, so what would you do for this one?
Just move the decimal around.
Good. Yes, we're going to move the decimal around, but then you would have to be careful about how you move the decimal. Now, let's look at what happened to 2.96. For 2.96 to become 29.6, that means the decimal point moved one place to the right, isn't it?
Yes.
So take note of that. And remember, decimal point moving to the right-hand side is like saying you're multiplying by 10 or multiples of 10, okay? So you're multiplying by 10. Now, look at 3.2. What would make 3.2 to become 32?
Times by 10.
Yes, exactly, times by 10. So that means both of them were multiplied by 10. In other words, the whole thing was multiplied by 100, isn't it?
Yes.
So that means the decimal point for 9.472 is going to move two places to the right-hand side, right?
Yes.
So that's going to make it 947, 947.2. Okay, so are you good with how to represent your working for this?
Yes, yes.
Okay, all right, no problem. Let's move on then. Okay, what does the next question say? Savio leaves his home at 7:30 to drive to work. He drives a distance of 50 miles. He thinks he drives at an average speed of 40 miles per hour. If Savio is correct, at what time will he arrive at work? Okay, so the formula for this kind of question is speed equals distance over time. So let me see.
So speed, sorry, distance divided by time. Divided by speed.
Yes, yes, but what they told us was the average speed. So that's 40, but they did not tell us the time. So that's what we will need to evaluate. So from that formula, speed equals distance over time. That means time will be equal to distance over speed. Okay?
Okay.
So that means the distance, what's the distance? He said 50 miles. So distance over speed, 50 divided by 40, that's 5 divided by 4. And that would give us one whole number. If the zeros cancel out, of course, that would give us 5 over 4. That would be one whole number 1 over 4, right?
Yes.
Okay. Now, see what we're going to do with that one whole number 1 over 4. Remember, he leaves his home at what time? 7:30, right?
Yes.
So let's work with one whole number 1 over 4. Remember, one whole number 1 over 4 is the same thing as 1 plus 1 over 4. Okay, so this is time about in hours now. So 1/4 of an hour is going to give us 50 minutes, right?
Yes.
So let's calculate one whole number 1 over 4 hours for 30 minutes. So 130, 1 hour for 30 was 8, right?
Yes.
Then 15 minutes after 8:30 is going to be 8:45, correct?
Yes. Yes.
So that means he arrives at work 8:45. So did you get the breakdown of the calculation?
Yes, I do.
Okay, good. All right. So let's move on. It says, in fact, Savio's average speed was greater than 40 miles per hour. How does this affect your answer to part A? Okay. So, you know what we're going to do? Let's just remind ourselves of the formula that we used back then, right? Speed equals distance over time. You remember that when I explained once, I can't remember which class it was, but I know that one of our classes, I gave you an example of how things play out when you have something equals something divided by something. I gave you an example using 2 equals 8/4. Okay, 8 divided by 4 is 2. So 2 equals 8/4. If we switch places and the 4 takes the place of the 2, what happens? You will see that 4 equals 8 divided by 2. That means if you increase the number on the left-hand side of the equal sign, the number at the number and you keep the 8 constant, the number underneath, the 4, the one that was underneath, which was 2, will now become, wait a minute, I hope I didn't mix it up. So I started with 2 equals 8/4, right? And then I'm now moving to 4 equals 8/2. So if you increase the 2 outside to 4, then the one that's underneath the 8 will reduce from 4 to 2. So in other words, increase the guy outside on the left-hand side, the one that's in the denominator will reduce. So what that tells me is that when you notice we switched, we said that speed equals distance over time. So that means if I increase my speed, remember, speed equals distance over time. Time is in the denominator. If I increase my speed, what do you think will happen to time?
He will arrive there earlier.
Yes, he will arrive earlier, so it will reduce. That's exactly what's going to happen. So that's what. So I think that's what they're expecting us to say there. How does this affect your answer to part A? So the time is going to reduce, and that means he's going to arrive earlier. Okay, so we can move on. Okay, so this one is talking about it's like probability too. Something that has to do with probability. It says 72 people did a test. 20 out of 32 adults who did the test passed. That means the remaining 12 failed. Okay. 6 of the children who did the test failed. All right. So this is we can't jump into any conclusions based on that yet. But we understand that 6 of the children who did the test failed. What does it say? Use this information to complete the frequency tree. Okay, so I have adult, child, number of those that passed. So I think that first box, right? That first box should have 72 inside. Am I right? The first
Yes.
box. Okay. So let's you want to help us just put a 72 there so we see what the thing looks like when we're done filling it up. Okay. 72. Okay. Yes, nice. 20, 12. Okay. So we know the number of children now is what? 40,
40.
right?
6 filled. 34.
So we'll have for that circle for child and 6 filled. So that means 34 passed. Oh, perfect. Nice one. Okay, let's move on. Okay, it says one of these people is picked as at random. Find the probability that this person is an adult who failed the test. Okay. So could you scroll up a bit? Let's see the number of adults who failed. Okay, so the number of adults who failed is 12. So that means number of required events and number of possible events. That's going to be 12 over 72. Yes. So 12 over 72. Wait a minute. Number of possible events. Hold on. I'm thinking. I'm not too sure we should conclude that the bottom should be 72, since the number of possible events for this one is targeted at adults. So I think it should be total number of adults. It shouldn't include the children. What do you think? I'm thinking it should be 12 over 32, not over 72.
It says one of the people is picked at random.
Okay, one of these people is picked at random, and it says find the probability that this person is an adult who failed the test. Okay, so you know what we'll do? Let's confirm the marking scheme. What does it say?
The mark scheme?
It says what? 12 over what?
Yeah, 12 over 72.
Okay, that's fine. Okay, it's fine. So it's 12 over 72. That's number of possible events. Okay, so 12 over 72 is actually 1 over 6 if you break it down, because 12 in 72 is 6. So yeah, 12 in itself is 1, 12 in 72 is 6. If you break it down to the lowest terms. Okay. All right, so can we move on now?
Yes.
Okay. Okay, it says here is a list of ingredients for making 10 scones. Ingredients for 10 scones. And then it goes on to say, Maya wants to make 25 scones. Work out how much sugar she needs. Okay, so they're only interested in sugar. So let's focus on sugar. Let's see. 40 grams of sugar is needed to make 10 scones. So to make 25, maybe what should we do for that guy? Okay, so to make 20, right? So let's work out what it would take to make 5. If 40 grams is needed to make 10, then 20 grams will be needed to make 5, right?
Yes.
Okay, so you know where I'm going, right? So to make 25, we would say what is needed to make 10, plus what is needed to make another 10 plus what is needed to make 5. So that's going to be 40 plus 40 plus 20. Did you get that?
Yes.
Okay. Okay, so the thought process is just simple. This whole 40 grams was needed to make 10. We're asked how many would be needed to make 25. 25 is 10 plus 10 plus 5. So we first figured out what it took to make 5, which is half of what it will take to make 10. Then we'll simply add up things as they play out. So that's 40 plus 40 plus 20. And that's going to give us 100, isn't it?
Yes.
Okay. All right. So let's move on. Okay. So it says increase 240 by 20%. Well, how would we go about this? There are two ways we could do this. We could first go about it by saying 20 over 100 times 240 over 1. Okay, we'll work it out, get the answer, take that answer and add it to 240. That's one way of doing it. Okay, another way of doing it is to, instead of doing 2 steps, we can increase 20. Since it says increase, all we just need to do is to add 20% to 100%, and then it will be 120% of 240. We will not need to do any other thing again. So 120 over 100 times 240 over 1. Which one would you prefer to do?
The first one.
The first one?
Yes.
Okay. All right. So now the first one, the advantage of the first method that I said is that it somehow explains itself. Now the second one, if you look at it carefully, it also explains itself, because I mean, the question said increase 240 by 20%. So increasing 240 by 20%, you are also increasing the percentage by 20%. Okay, that's simply what you are doing. So, but if you understand the first one better, it's fine. So, do you want to do that on the screen? Let's see you do it just for practice. 20 over 100 times 240 over 1. Let's see how you take out the zeros.
240 over 1.
Yes, 240 over 1. Okay, all right. So you can take out the zeros. Let's see them, and then we'll see what we have left. Yes. Can you see another zero there? The second zero in 100 and the zero in 240. Yes, perfect. So you're left with 2 times 24, which is 48. So that's 240 plus 48. So that will give us 288. Okay, so I think we can move on now. All right. So we can go on now. It says the diagram shows 3 identical rectangles, A, B, and C. Okay, they're identical, but some things are not so identical about them. It says 5 over 8 of rectangle A is shaded. Clearly, that shows like 5 over 8. 9 over 11 of rectangle C is shaded. Okay. What's the question? It says work out the fraction of rectangle B that is shaded. Okay, so let's look at these guys very well. Rectangle A is 5 over 8 that is shaded, right?
Yes.
So the question now is this. That part that is not shaded, what do you think the fraction is for that part that is not shaded?
The 5.
What did you say?
It's the 5.
No, so you remember this is similar to probability. Similar. Why did I say it's similar? Because it has to do with fractions. So if 5 over 8 is shaded and total fractions is usually 1, just like total probability is 1. So what do you think that remaining part will be? Your screen is no longer sharing. I can't see your screen anymore.
Okay, so the unshaded part will be 3 over 8.
Yes, it will be 3 over 8. Yes. So I can't see your screen anymore. Okay, it's coming up now. Okay. I can see it, but the question is not showing yet. Okay, it's back now. Okay, so if that's 3 over 8 that's left up there, let's do the same thing for rectangle C. Rectangle C, we are told that 9 over 11 of rectangle C is shaded. So the part that is not shaded is going to be 2 over 11, right?
Yes.
So now, do you know why I'm looking at the one that's not shaded for the other guys? That's what's going to tell me what's not shaded for B. Did you get that?
Yes.
Okay. So you know what I'm going to do? I'm going to say 3 over 8 plus 2 over 11. That's the fraction that's not shaded for B. Now, I know that we're being asked what is the fraction that's shaded for B. If we know what is being shaded for B, if we know what is not being shaded for B, all we need to do is to subtract it from 1 and we'll find out what is shaded. Does it make sense?
Yes.
Okay. So 2 over 11. So can we work it out? 2 over 11 plus 3 over 8. Let's quickly work that out. 2 over 11 plus 3 over 8. You can do the LCM thing. It might not work out that first way that you did it, but you need to do LCM. 2 over 11 plus 3 over 8. Plus 3 over 8. Okay. So the LCM of 11 and 8 clearly is, I guess it's only 88 that will do the trick. So you just put your 11 in 88. Yeah, exactly. You can do that. That's fine. So that would give us 16 over 88 plus 33 over 88.
You see 33?
Yes, 33 because of the 11 times 3. Okay, so what would this amount to? 49. Okay. All right. So you know what to do, right? So this fraction that you just did now is the fraction of B that is not shaded. So we're going to subtract it from 1. So you can just do your 88 over 88 minus 49 over 88. Yes, or yes, okay, yes, you can write it like that first. 1, yeah, exactly. 88 over 88 minus 49 over 88. Okay, all right, you've already calculated it. That's good. So that's 39 over 88. Okay, so yes, that's the fraction of b that is shaded. Okay, so. All right, so can we move on now?
Yes.
Okay. Okay, this one is talking about ages in years of 15 people. What does it say? Show this information in a stem and leaf diagram. Okay, so do you know how a stem and leaf diagram looks like?
Yes.
Okay, so do you want to represent it? I'm seeing 1, 2, there are 15. Okay. Okay, so can you represent it? So I think there's something about the ages that are all the same. I think all of them, those ones will be on one branch. I'm not too sure. But okay, let's see what you come up with. So just can you do a rough sketch of the stem and leaf diagram? Let's see. Okay, are those lines below there a guide for you to use?
Yes.
Okay, all right. Okay, go ahead then. Go ahead. Okay. 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 You have 25 in 2 places, right?
Yes.
Okay. 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 27 in 3 places. Okay. Oh, there's 126. Oh, nice. Then there's a 28. Oh, okay. There is 128 and 129. Yes. Okay. 8 and 9. Oh, nice. Nice, nice, nice. Okay. Then we have 33 and 37 in 2 places. Okay. 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 And then
Sorry.
okay.
Um, so,
Yeah. 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 Then 145 and 147. 5 and 7. Okay. Okay, nice. Okay. Yeah. Okay. Okay. Nice. 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 Okay. 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 So I'm just interested in your key. Why did you represent your key like that? You said 1/7, right? Why did
Yes.
you put that? Why did you put the like a? Is that a what's that? Is that a multiplication sign behind it?
Years. It says 17 years. So
Okay. All right. So okay, it says here the centimeter grid shows the plan and the front elevation of a cylinder. Okay, the plan and then the front elevation. Okay, okay, I think I understand it. The front elevation is like you're looking at it from the side. It says, work out the volume of the cylinder. Give your answer in terms of pi. Okay, we know that um, the volume for any solid shape is simply the, what do you call it? The area times the height. The area of the shape, which in this case is the circle on top, times the height. So the question now is, what is the area of this circle? Now, they told us that it's a centimeter grid. That means, if I'm to assume, each of those boxes there is 1 centimeter. So let's see what the radius of this circle would be. That's going to be 1, 2, 3. That's going to be 3 centimeters, right?
yes.
Okay. So the area of the circle, remember, volume of a cylinder is the area of the shape on top times the height, the vertical height. So in this case, the area of this circle is going to be pi r squared. That's pi times 3 squared, which is 9 pi. Okay. So let's now work out the height. So the height, let's look at the front elevation. The front elevation. So we're going to count only the rectangles on the side. Somehow I think it looks like a square. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, it's not even a square, it's a rectangle. Okay, but it's the vertical that we're counting. So I'm counting 1, 2, 3, 4, 5. So the height of this guy is 5 cm. So that's going to be 9 pi times 5, which is going to give me 45 pi, right? I can do that.
Okay, so you did 9.
Did you understand how I got the 9?
Can you go again through that again, please?
Okay, should I go through it again?
Yes, please.
Okay. So I started by saying that the volume of any solid shape, okay, a cylinder inclusive, is given by the area of the shape on, that's the shape, that the shape on top of that solid shape, the plane shape on top of that solid shape, which in this case is a circle, times the vertical height. Now, if you want to remember what I just said, just remember the volume of a cuboid. A cuboid is length times breadth times height. And if you remember, length times breadth is the formula for the area of a rectangle. Of course, that's the shape, the plane shape for a cuboid. Okay, but now we're not dealing with a cuboid, we're dealing with a cylinder whose plane shape on top and the bottom is a circle. Okay, so that's going to give me the area of this plane shape is going to be pi r squared for a circle. Now, if we follow what the question told us, that this is a centimeter grid, then that means each of those boxes is 1 centimeter. So I'm to get the radius of this circle, I'm going to count from the circumference to the center, which is 3 boxes. I think you got that part. So that's 3 centimeters. So the area of this circle is going to be pi r squared. That is pi times 3 times 3. And that's going to give me 9 pi. Okay. Did you get it up to that point? Eleanor, are you there?
Yes, sorry.
Okay. Did you get the explanation of that point?
How you got to pi 9.5?
Yes. The pi times 3 times 3. So the 3 times 3 gave us 9. So that's why we now have 9 pi.
Okay, then the 9 times the 5, and then that's why it's pi 45.
Yes, but the good thing about it now is that they didn't ask us to evaluate what the pi is. So we can leave our answer in terms of pi. So that's why we didn't need to say 9 times 22/7 or stuff like that. So we just leave it as 9 pi. Now, that's the area of the circle. But now this circle is the top and bottom of a cylinder. So there's a height in between the circle on top and the circle at the bottom. So that's what this other shape is for. And that's us looking at the cylinder from the side. And looking at the cylinder from the side, the height, I told you the height is the vertical height, not the width. Okay, so it's the height. So we're going to be counting the squares along the vertical side. And if you count those squares, you have 5 squares. Can you see that?
Yes.
Okay. So now, if I have 5 squares and those 5 squares, each of them is 1 centimeter, that means that the height of my cylinder is 5 centimeters, right?
Yes.
Now remember how I started. I said the volume of any solid shape is the area of its plane shape times its vertical height. Okay, so that's going to give us 9 pi that we already have for my circle times 5. Okay, and since it's a multiplication thing, the numbers will multiply themselves, but the pi will still stay. So that's where I said 9 times 5 is 45. So 9 pi times 5 is simply 45 pi. Did you see that?
Yes.
Okay. All right. So that's it. So the final answer for this is going to be 45 pi centimeter cubed, because it's a volume, cm raised to power 3. Okay, so are you good with my explanation, or is there a part of it that you didn't get?
Yes, it's good.
Okay. So can we move on now? All right. So let's see. Okay. Okay, so can you solve this one?
Yes.
Okay. Let's see you give it a try.
So you add 27 to both sides. I'm sorry to
Yes, you can. Yes, you can annotate on the. You can do it on the paper.
Okay.
Perfect. Perfect. Yes. X less than 5. Okay. Yes, that's fine. Okay, let's move on to the next one. Okay. Please. Sorry, let me just say something about that one that we did now before we leave it. Um, just to remind us of a few things. Now, did you notice something? The sign is still remained as less than. You remember when I was talking about, I think it was when we first mentioned them inequalities, that I said that when you are dealing with inequalities, it looks as if you are dealing with normal linear equations, right? It's just that this time, instead of you to have equals to, you have less than, or you have greater than, one of them will come to play. However, the difference between inequality and equations is that the signs can be reversed. Okay, so what are the things that can reverse the signs? When you divide or multiply by a negative number. So in this case, we did not do any of that, but let's just pretend. Let's just pretend. Okay, we had, instead of you to have a minus 7x less than 35, you had minus 7x less than 35. What would have happened is that you would have had to divide both sides by what? Minus 7. And guess what would have happened? Your answer would have been x greater than minus 5. Did you get that?
Yes.
Uh-huh. I should just say that so that if we don't come across one like that before the exam, you would know what to do if you see it, something like that. Okay, let's move on then. I just felt I should say that. Okay, the next one says write 124 as a product of its prime factors. This is quite straightforward, right? You want to start with 2. I would advise you start with 2. 124 is 2 times what?
2 times 62.
2 times 62. Keep breaking it down again. That's going to be 62 is 2 times 31, right?
Yes.
And 31 is a prime number, so we can't break it down further. So it's simply going to be 2 times 2 times 31, 2 raised by 2 times 31. Okay. All right. That one was pretty fast, right?
Yes.
Okay. So you know what I noticed, and I think it's something that happens in exams like this. Some questions are quite short, okay, and they do it deliberately just to help you so that you find yourself having more time to attend to other questions, which may actually be lengthy. Okay. Okay, so let's move on. It says a delivery company has a total of 160 cars and vans. Okay. The number of cars, the ratio of the number of cars to the number of vans is equal to 3:7. So that means that's just a ratio. Okay, so let's just keep that as a ratio. Cool. Move on. It says each car and each van uses electricity or diesel or petrol. Okay, that's an interesting variety of or sources of energy. It says 1/8 of the cars use electricity. 5% of the cars use diesel. The rest of the cars use petrol. Work out the number of cars that use petrol. You must show all your working. So, let's see. You know what we're going to do first? We need to find out how many cars we have from the start. So, how do you think we're going to do that? Any ideas?
160.
Any idea?
160 divided by.
Yes, 160. 160 what? What did you say? I heard you say 160. I didn't hear the rest.
160 divided by 10.
Divided by 10. Okay, but that's not all, right?
No. So 16 times 3.
So you need to complete it. 160 divided by 10. What's next? What are you going to do next to get the number of cars?
16 times 3 and 16 multiplied by.
You would multiply it by 3.
Yes.
Okay, so I understood. Yes. Times 3, right?
Yes.
Yes. So yes, I like that. I like how you went about it. So that would help us to know. Yes, 16 times. Yes. So that's 48, right?
Yes.
Sorry, it seems like you have a cold.
Yes, I do, sorry.
Okay. Okay, sorry about that. Okay. All right. So that. Sorry, my network fluctuated a bit. Can you hear me now?
Yes.
Okay. All right. So I was saying for the number of cars we have is 48. Okay. So now we now know the number of cars. 1/8 of 48 uses electricity. So let's take that out. 1/8 times 48 is what? That's 8 in 48 is 6, isn't it?
Yes.
That means 1/8 times 48/1 will give us 6. So we now know that the number of cars that use electricity is 6. Keep that by the side. 25% of the cars use diesel. 25% is as good as 25 divided by 100. That is 1/4. Okay, I need you. I'm deliberately saying it this way so that you get used to it. 25% is as good as 1/4 because 25 in itself is 1, 25 in 100 is 4. So that's as good as 1/4 times 48 again. Remember, 48 is our number of cars. We're not dealing with vans. The question doesn't seem to be interested in vans. So 1/4 times 48. 4 in 48 is 12. Okay, so that means we have 6 for electricity, we have 12 for diesel. So Do you want to help us do the math? 6 plus 12, that's 18.
Yes, it's 18. Sorry. Hello?
Okay. Sorry, Noah, can you hear me now?
Yes.
Hello, Noah, can you hear me?
Yes. Hello? Hello?
Hello, can you hear me, Noah?
Yes, I can.
Okay. All right. Okay, I think I went in and out for a while. Okay, so let's continue. So I was saying that since I'm not sure where I left off, but 1/8 of 48 will give us 6, and 25% of 48 will give us 12. Did you get my explanation up to that point?
Yes.
Okay. So let's add 6 plus 12 and then subtract it from 48. That will tell us the number of cars that use petrol. So 12 plus 6, that's 18, right?
Yes.
48 minus 18 will give us what?
Minus 16 or 18?
Minus 18, sorry.
30.
30. Okay. All right, so that's good. That's the number of cars that use petrol.
30.
Okay. So, yes, 30 cars, yes. Okay, so did you get the explanation?
Yes.
Okay, all right. Okay, so let's move on. Okay, so this question has to do with standard form. It says you should write it as an ordinary number. Okay, so I have 1.63 times 10 raised to power minus 3. Remember what I said back then in the last class when we were looking at indices, that anytime you see a number raised to a negative power, right, it's as good as 1 over that number raised to the power but without the minus anymore. So what that means is that what you are looking at here, 1.63 times 10 raised to power minus 3, is simply the same as 1.63 divided by 10 raised to power 3, which is 1000, right?
Yes.
Okay, so you know what to do, right? The decimal point will move to the left how many times?
3 times.
3 times. So what will it now become?
0.00.
You can write, yes, you can write it down if you want. If you're not too sure how it will look, you can write it down and move the decimal points so that you can see what it will come to. Okay, yes, that's correct. Okay, so let's go to the next one. Of course, the next one looks like the opposite of the first one. It says write it in standard form. So what would this number be in standard form?
4.3 times 10 minus 5.
Okay, now there will be no minus in this one. You know why there will be no minus?
Why? Oh, because it doesn't turn to more zeros.
Yes, the decimal point. So this is the trick about standard form. You are going to ask yourself, in which direction will, if the decimal point were moving back to the original number, which direction will it move, right? So if the direction will move towards the right hand side to give you back the original number, then the sign on the power of 10 will be positive. But if it would move to the left hand side to give you the original number without standard form, then it will be minus. Now if you look at the number that we just left off now, 0. What? 0.00163, you can clearly see that the decimal point will move to the left to get back to the original number. But for this one, 4.38 times 10 raised to power, that should be 5 times 10 raised to power 5. You will see that if you wanted to take it back to the original number, the decimal point will move to the right hand side. So it should be positive, not negative. Okay, did you get that?
Yes.
Okay, all right, so that's 4.38 times 10 raised to power 5. Okay, so what is the next thing we have there? I have 4 times 10 raised to power what? 3 times 6 times 10 raised to power minus 5. Okay, it says you should give your answer in standard form. Now, what do you think will be the answer of that guy, that third one? What do you think will be the answer? It's, yes, go ahead.
24 times 10 minus 2.
Yes, times 10 raised to power minus 2. But there's a small issue there. It's 24 is not exactly in standard form. For 24 to be in standard form, you have to make it 2.4. So that's going to give us, now 24 is 2.4 times 10 raised to power 1, isn't it?
Yes.
Oh, perfect. Nice, nice. Minus 2 plus 1. Okay, that's minus 1. Okay, we're good. We're good. All right, let's roll. Let's move. All righty. It says here is a regular hexagon and a regular pentagon. Okay, what do they want? It says work out the size of the angle marked X. You must show all your working. Okay. So the question is, what's that? We need some facts from this. But you know what fact we are going to use? There's a mathematical fact for exterior angle of any polygon. Okay, so take note of this. The exterior angle for any polygon, the sum of exterior angles of any polygon add up to 360. Okay, so that's where we're starting our calculations from. We have to start with a fact. Okay, so that it's not like we're just guessing things, especially with this kind of shape, which no angle was given to you. So that means whatever concept you come up with must be a mathematical fact. So let me say it again. The mathematical fact we're starting with is that the sum of the exterior angles of any polygon at all, any one, will always add up to 360. So why did I say exterior? Because if you see that angle X there, it's outside the two shapes. Did you notice that?
Yes.
Good. Now, I want you to, in your mind's eye, okay, or I don't know, maybe you can use the pen there and just do as if you are doing a dotted line. That side that the hexagon and the pentagon share, just do as if you are doing a dotted line straight that passes through X. Can you do that? There's something I want. Yes, that line, you see the side that they share, right? Just do a line as if you are drawing a line through X, dotted line that just continues that side that they are sharing. You don't have to use a ruler. Just do a sketch, a dotted line, dot, 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 passing through X. So it will kind of divide X into two. I didn't say two equal parts, but to divide X into two. Okay? Okay. Yes. Yes. Okay. Can you make the dots, not like small dots, like, dash, 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 those kind of dots? Yes. Yeah, more like that. I like that. Okay, that's good. Now, do you know why we did that? It's to make it clearer that the one on the right hand side of the dotted line that you just did now, that is the exterior angle of the pentagon, and the one on the left hand side of the dotted line is the exterior angle of the hexagon. So guess what? The exterior angle of the pentagon plus the exterior angle of the hexagon together will give us X. Do you agree with that?
Yes.
So the question now is this: what is the size of one exterior angle of the pentagon, and what is the size of one exterior angle of the hexagon? Now, the answer to that question can be gotten from that first fact that I stated, that mathematical fact that I stated. And what is that? That the sum of exterior angles for any polygon is 360. Now imagine this. if I know that a hexagon is 6-sided shape, there will also be what? There will also be what? 6 exterior angles, right?
Yes.
Okay. So that tells me that one exterior angle of my hexagon, I'll simply divide 360 by what? 6. Since they are all equal, it makes sense because it's a regular hexagon, and regular polygons have equal things. All the things are equal sides, equal interior angles, equal exterior angles. So I can confidently say that one exterior angle of the hexagon is 360 divided by what? 6. Did you get that?
Yes.
So that's going to give me 60, isn't it?
Yes, yes.
So we've established the left-hand side of x. Let's establish the right-hand side of x. The right-hand side of x is the pentagon. That's a 5-sided shape. So we're going to be dividing 360 by 5 to get the value of 1. Your battery is low, but we're almost done. But anyway, if you're not too sure it will take, I think you should just connect it. So 300, that's going to give me 72. Am I right? 72, right?
I believe so, yes.
This is 72, right?
Yes.
Okay, good. Can you see what we're going to do now? The next thing we're going to do now is to say left-hand side 60 plus 72, which will give us 100 and what? 32. Did you get the calculation up to that point? Your screen is no longer sharing.
Oh, sorry.
I can't
Yes.
see your screen anymore. Okay. Okay, I can see it now, but the question paper is still coming up. Okay, so you understood my explanation up to the end?
Yes.
Okay. All right. So, were you able to write down the workings, or do you want to write it down now?
I'm writing down. No.
Okay. All right. Okay. But I hope you understood where I started from, right?
No, yes, yes.
Okay, good. Because it's very important. Um, there are some questions in mathematics that you can find 5 different ways of arriving at the same answer. But for this one, it's well, if there are more than one way to get to the right answer, I can assure you that the other ways to get to the same answer that we've just gotten would be twice as long as we took to get to our own answer. Yes, because we had to start with exterior angles. If you start with any other thing, the other options will be to start from interior angles, and you would spend almost more than maybe 30 minutes trying to get to the fact for exterior angles. Someone else might say, oh, let's divide all the shapes into triangles and start. That's a whole lot of you know stuff you don't want to go into. Okay, so let's move on. Oh, this one looks like a graph thing. You can do this yourself, right? You're just substituting values. Substitute -1 into the, but okay, so let me not assume anything. Let's try to fill this thing up. Let's try and fill this up. So what would you get if you were substituting, for instance, -1 into that equation? What are we going to get?
Say -1 squared.
Good, -1 squared, and we all know that -1 squared is what?
1.
Good, it's 1. I mean, clearly, -1 times -1. The minus sign will cancel the minus sign. You know, minus times minus is plus. And 1 times 1 is 1. So the answer is 1. Then -3x. Remember, the x is -1. So -3 times -1. What would you have?
3.
Good. So what you now have is 1 plus 3 plus 1. Your screen is I can't see your screen anymore. But what would that give you? 1 plus 3 plus 1.
5.
5. Good. So that means 5 is your value for y in that box. So you can put 5 there. So you see, it's quite important. In fact, very important that you fill that table of values correctly, so that your graph would equally be correct. Okay, so I'm having 5 there. What next? So the next one is 2. So let's put 2 into it and see what you get. 2 squared is 4. 4 minus 3 times 2. 3 times 2 is 6. So we have 4 minus 6 plus 1. What would that give you? 4 minus...
Sorry, -1.
Yes, -1, because that's -2 plus 1. So that's -1, yes. Then we go on to the next one. 3 squared is 9. 9 minus 9 plus 1. That's 1, isn't it?
Yes.
And then finally, 4. 4 squared is 16. 16 minus 12 plus 1.
5.
Yes, that's 5. So you technically have all your values for your graph. Okay, so I think it's going to give, of course, I expect it to be a curve. I mean, it's expected that it's a curve. It's going to be shaped like a U or something. Okay, so I guess you can handle it, right? You can handle
Yes.
the drawing of... Okay, so we can to the next question. Now, sorry, let me just say something about what it says there about estimates for the solution. Estimate for solution is where the graph cuts your x-axis. Okay, so by the time you draw your graph, you will notice that the graph will cut the x-axis in 2 places, isn't it?
Yes.
Good. So those 2 places that it cuts the x-axis or intersects with the x-axis, those are the places that are the solution. Okay, so I'll leave that for you to handle. Let's move on to the next question. Okay, what does the next question say? Oh, it has to do with a cube. It says here are 2 cubes, A and B. And what does this say? Cube A has a mass of what? 81 grams. And cube B has a mass of 128 grams. It says work out the density of cube A to the density of cube B. Okay, that's a ratio, sorry. So work out the ratio of the density of cube A to the density of cube B. That's simple. Do you remember the formula for density?
Is it the the mass over the mass?
Yes, mass per unit volume. Mass per unit volume. Whenever you hear that word per unit, just know that it's division. Mass divided by volume. So what's the mass? They've given you the masses 81 and 128 respectively. But now the question is, what's the volume? You remember what I said about volume of a cube or cuboid? Length times breadth times height. Since it's a cube, it's simply L raised to power 3. Everything is the same. So the volume for A is 3 raised to power 3. And the volume for B is 4 raised to power 3. So what is 3 raised to power 3? That's 3 times 3 times 3, isn't it?
Yes.
That's going to give us what?
27.
Good, 27. And then for B, we have 4 times 4 times 4. That's going to give us what?
Um, 60.
That's 64, right?
Yes.
64. Okay. So the density for A is going to be simply 81 over. So do you want to write it down? Let's write it down. Something we might see things that will cancel themselves out. So that's going to give us 81 over 81 27. So just write it down. 81 over 27.
Wait, so dividing it by the.
That's the density for A. 81 over 27. For A, yes, just write it down. 81 over 27. Then for B is 128 over 64. Now, remember that ratio is also division. Am I right?
Yes.
Good. Now, and remember that when you're dealing with fractions, when you have a division, that division can change to multiplication. What will happen to the guy on the right-hand side?
Pardon?
So now look, this is what I want you to do for me. Can you put the ratio sign between those two fractions that you just wrote now? Just put the ratio sign between them. The dot dot. Okay. Okay. Okay, good. So now we want to translate that dot dot into what it actually is, which is what? Division. So on the next line, you're going to write for me 81 over 27 divided by 128 over 64, which will now translate to 81 over 27 times 64 over 128. Can you do that?
How will I solve this with the calculator?
What did you say?
How will I solve it with the calculator?
Yes, don't worry. Let's write that down first. We'll see how things are going to cancel out. Yeah. Over 27.
Does the fraction change? Other side. Or stays the same?
Okay. That what your times looks like a plus. You want to change it so that it looks like a times, really, not a plus. Yes. Okay. So 64 over 128. Okay. Okay. So let's see. Um. So let's see. I think let me see. What do we have here? So maybe we should deal with the 64 and 128 first, right? 64 divided, sorry, 8 into 64 is 8. Then 8 in 128, 8 in 12 is 1, remainder 4. 8 in 48 is 6. So can you just do that cancelling? We're cancelling 64. So you can put a stroke across 64 and put 8 there. Put a stroke across 12, put 1, and then remember a small 4 there beside the 8. And then just put 6 there. Yes. Yes. Remainder 4. So you can put the 4, just a tiny 4 close to the 8. And then 8 in 48 is 6.
Sorry, where does the remainder 4 go?
You put the remainder beside the 8, a small number 4, just a small 4, so that we know that that's the remainder, 48. So 8 in 48 will give us 6. No, not beside that 8, the one underneath, not that one, the one underneath. Yes. Okay, you want to put it in front, just like a small thing, so that we don't confuse it for something else. Okay, that's fine. Okay, so 1848, you can now cancel it and then write 6 beside the 1 that you've written down there. 1848. Okay, 6. Okay, then you can now do 8. 8 will go into itself 1, and 8 will go into 16 2 times. Yeah, 2. Okay, good. Then let's deal with the 27 and 81. Okay, so for 27 and 81, you can do the same thing. You can use 9 for 27 and 81. 9 in 27 is 3. 9 in 81 is 9. 9 in 27 is 3. Yes, you can count. Yes, good, good. Nice one. And 3 in itself is 1, and 3 in 9 is 3. Okay? Yeah, yeah. Okay, that's good. Excellent. So let's see what we have finally. So we have 3 over 1 times 3 over 2. Is that what I think that's what you have, right?
No. It's 1 over 2. 1 over 2.
Sorry, 1 over 2. Sorry. 3 over 1 times 1 over 2. So, yeah, 3 over 1 times 1 over 2. So that's going to be 3 over 2, isn't it? Which is as good as 3 is to 2. Yes, so you can just leave it at 3 is to 2. That's the ratio format. It was actually a ratio we started with. So that's it. Okay, so are you good with it?
Yes.
Okay. All right. Okay, so how far have we gone? How many more questions are left?
1.
One more, right?
Yes.
Okay, all right. Okay, cool. Okay, so let's go to that one. So that we just finish up. I know we've gone past our time, but yeah. Okay. Okay. It says write down the value of sine 30. Hmm. Okay. So I don't know how they want us to get this. Like, is this something we're expected to remember? So I know from my own, several calculations, sine 30 is 0.5. Okay. But do you remember that? Do you remember that what the value of sine 30 is?
0.5.
Yes, 0.5. Yes. Okay. So you said this is the last question, right?
Yes.
Okay. Okay. All right. So, um, okay. So, I think that's it for today. But, um, would you, you know what? Maybe so that we don't keep pushing it forward. Would you be able to share the ones that you were able to solve from those ones I sent to you tonight?
Pardon?
The ones you said you were able to solve, would you be able to share them with me tonight via on WhatsApp?
Okay.
Okay. So, if you can share it with me, I would work towards explaining the other ones that you don't understand in our next class.
Okay.
Yeah. All right. Sorry. Just try and keep yourself warm so you take care of the cold. Okay. All right then. You have any questions?
No.
Okay. All right. Okay then. Then do enjoy the rest of your evening.
Okay, you too.
Um, I'm thinking if I'll let you know if Saturday is workable. If it is, I'll put it on the group. I'll let you guys know on the group. Maybe Saturday and Sunday. I'm not sure, but if we can, let's just make the best use of the time we have.
Okay.
Yeah. All right. So have a good night.
You too. Thank you.
You're welcome.